So in this sessions, we'll be looking into the possible image-based questions from biochemistry. Okay, moving on to the first question. Yes, so first we'll start off with the question. Here, all of the following are correctly matched enzyme with the concerned organelle except. See, if you see here, there is except. Okay, so all of the following are correctly matched. Enzyme with the concerned organelle except. So they are asking you to find out which one is wrong. Okay, everything is right, which is wrong. This is a question. So when you're go through the question, you have to spend some time to go through the question completely. Okay, you have to read till the end of the question except. Okay, then only you should proceed for answering the question. So now we look into the options. The first one is plasma membrane, adenyl cyclase, mitochondria, ATPase, endoplasmic reticulum, glucose 6-phosphatase, none. So these are the options. Now we'll look into the organelle and their specific marker. If you see nucleus, DNA and RNA. Okay, DNA and RNA are the markers of nucleus. In mitochondria, there are different pathways or reactions which is happening inside the mitochondria. For example, pyruvate dehydrogenase complex, which oxidizes pyruvate to acetyl-CoA, that is happening inside the mitochondria. And electron transport chain is happening inside the mitochondria. Yes, where we are generating ATP. Okay, ATP synthase. Yes. So the ATP synthase which is present in the inner membrane, that is the marker enzyme for mitochondria. Okay, you can remember one enzyme which is present inside the mitochondria. The next one is lysosome. Okay, lysosome, the enzyme is cathepsin. Next is Golgi complex. The enzyme here is galactosyl transferase. As we all know, the ribosomes which synthesize the protein, those proteins will come via Golgi complex and it will undergo some modifications in the Golgi apparatus. Then only it will be either it will be utilized by the cell which is synthesizing it, or it will be secreted out of the cell. So that group attachment, group transfer, those things will happen in the Golgi apparatus. So you can remember this way. Okay, this is a post-translational modification which is happening to a protein where a galactosyl transferase will attach a galactose to the protein. So the enzyme here is galactosyl transferase. Okay, microsome is nothing but when we centrifuge the cell, it results in the formation of microsomes which are nothing but endoplasmic reticulum. Okay, in endoplasmic reticulum there is an enzyme called glucose 6-phosphatase. This is the enzyme which is going to release the free glucose. Okay, the enzyme glucose 6-phosphatase, it is present in the endoplasmic reticulum. They can ask either endoplasmic reticulum or microsome. When you centrifuge the cell, it will result in the formation of microsomes which are nothing but endoplasmic reticulum which is forming the microsomes. Next is cytoplasm. Okay, in cytoplasm you have this enzyme lactate dehydrogenase. So lactate is even though fatty acid synthesis is happening in the cytosol, and we use the enzyme lactate dehydrogenase which participates in anaerobic glycolysis. Okay, that as a marker for cytosol. Okay, so these are the marker enzymes for each cell organelle. So now we can go back to the question and see which one is wrong. Plasma membrane, the enzyme adenyl cyclase, this enzyme will convert ATP to cyclic AMP. This enzyme is present in the plasma membrane. Okay, yes, so this option is right. Yes, adenyl cyclase which is present in the plasma membrane, it is the marker of plasma membrane. And the next is ATPase. Okay, this is present in mitochondria. Yes, ATP synthase is present in the mitochondria. The next is endoplasmic reticulum and glucose 6-phosphatase. They can also ask as microsomes. Okay, so either microsome or endoplasmic reticulum. Yes, endoplasmic reticulum, the marker enzyme is glucose 6-phosphatase. If you see here, all the options are right. Okay, so here the right answer is none. Okay, all of the following are correctly matched enzyme with the concerned organelle except everything is correctly matched. The one, nothing is wrongly matched. So the option answer, right answer here is none. Okay, yes. Yes, we'll move on to the next question, which is from the chemistry of carbohydrate. They can give the fact statements like this, and they might ask you to find out which one is right and which one is wrong. Here, the question is mark the true statement. So, when they ask true, false, You have to be conscious before reading each and every options. Mark the true statement regarding glucose. They are asking which one is right about glucose. Yes. So epimer of glucose is galactose, formed by the epimerization at carbon 4. Okay. This glucose exists as furanose ring most of the time. The next option is alpha amylase converts aldehyde. The CHO is aldehyde to glucose. Glucose is present in the body as L form. So we will rule out one option by one when you get these kind of questions. Yeah, first we will start with epimers of glucose is galactose and it is formed by epimerization at C4 carbon atom. Yes, so glucose has two epimer, one at C4, one at C2. The C4 position epimer is galactose. Yes, and the C2 position epimer of glucose is mannose. So the first statement here is epimer of glucose is galactose. Yes, we agree. Galactose is an epimer of glucose, and that at which position it is at C4. Yes, the first option is right. And glucose exists as pyranose ring. If you see, glucose can exist as pyranose. Any compound which has more than 5 carbon compound tends to form a ring. Okay, it exists as pyranose or furanose. If we see glucose predominantly, since it is 6 carbon compound, it predominantly, okay, it also exists in the furanose form, but predominantly most of the time it exists in the pyranose form. Okay, beta D glucopyranose. Beta D glucopyranose is the predominant form of glucose. Okay, so this is wrong. Alpha amylase converts CHO to glucose. No, the function of alpha amylase is to break the glycosidic bond between the glucose. For example, in case of starch. Okay, so starch, it is a homopolysaccharide which is made up of glucose. So amylase will break the bond between glucose and glucose. Okay, it breaks the bond between glucose and glucose. It will not convert CHO group to glucose. So this amylase will cleave glucose from the starch one by one by breaking the glycosidic bond 1,4 glycosidic linkage. Okay, glucose is present in the body as L form. No, this is wrong. Glucose predominantly will be present in the body in D form. This we have to remember. This is the fact. Glucose will exist predominantly in the body in the D form. Amino acids will exist predominantly in the body in L form. Okay. Glucose predominantly will exist in the body in the D form, whereas amino acids will exist in the body in the L form. So this is the fact which we have to remember before moving back to the epimers, the isomers. Okay, so the right option here is epimer of glucose is galactose, which is formed by epimerization at C4 position. So when we get this kind of question, first you have to make sure whether they are asking a true statement or a false statement. Then you have to fix in your mind that you have to look for the correct statement. Okay, then you have to rule out option one by one. Yes, so if you see here, this is D-glucose. As I said, yes, glucose and galactose are epimer. Galactose is fourth epimer of glucose, whereas mannose is second epimer of glucose. So, what do you mean by epimer? Okay, so yeah, so isomers are nothing but compounds with the same chemical formula but different structural formula. Okay, so how they are classified? Functional group isomers, enantiomers, anomers, and diastereoisomers. Functional group isomers. It is very simple, right? As the name indicates, the functional group. If you see glucose, the functional group is aldehyde. If you see fructose, the functional group is ketone. Okay, even though they have the same chemical formula, structure-wise, if you see, glucose has an aldehyde functional group, fructose has a ketose functional group. So they are glucose and fructose, they are functional group isomers. Okay, this is related to functional group. Okay, so if you see the structure of glucose, yes, so this is a 6 carbon compound, right? Yes, so if there is a difference with respect to functional group, though that kind of isomerism is called functional group isomerism. Okay, the next one is D and L isomerism. If you see D and L isomerism, that is related to, Okay, that is related to C5 carbon atom, which is nothing but penultimate carbon atom. We know sixth carbon is the last carbon. Okay, the carbon which is just above, or which is just above the last carbon atom, is called penultimate carbon atom or reference carbon atom. Okay, so when there is difference in the orientation of hydroxyl group with respect to this penultimate carbon atom or reference carbon atom, it will result in D and L isomers. If the hydroxyl group is on the right hand side, if you see this picture, with respect to penultimate carbon atom or reference carbon atom, the hydroxyl group is on the right side. So this is D glucose. If the hydroxyl group is on the left hand side, then it becomes, if it is on the left hand side, it becomes L. So this is D and L isomerism. Okay, so they are non-superimposable mirror images of each other. So this is D and L isomerism. Suppose if there is a difference in the arrangement of spatial arrangement of hydroxyl group with respect to carbon atom other than the penultimate or reference carbon atom, they are called diastereoisomers. That means if there is difference in the arrangement of hydroxyl group with respect to C2, C3 and C4. Okay, it can be either C2, either C3 or either C4. Everything together they come under diastereoisomer. Okay, everything will come under diastereoisomer. Epimer is the change in the orientation of the hydroxyl group with respect to one carbon atom other than the penultimate carbon atom. That means it can be only C2 or only C3 or only C4. Then that becomes epimer. So, epimer is a type of diastereoisomer. Diastereoisomer is difference with respect to C2, C3 or C4. Epimer is either C2, either C3 or C4 with respect to only one carbon atom, but that is other than the penultimate carbon atom. So, this is how we classify isomers. So, we saw functional group isomers, enantiomers, diastereoisomers, where there is a difference with respect to carbon atom other than the penultimate carbon atom. Epimer is either C2 or C3 or C4. Okay, so this is how we classify isomers. The last one is anomers. If you see the structure of glucose, okay, if you see the structure of glucose, C2, C3, C4 and C5. These are the four asymmetrical carbon atoms. Okay, so glucose, since any compound with more than five carbon atom will tend to exist in a ring form, right? Will tend to exist in a ring form. Okay, either furan ring or pyran ring. Either we can label them as either furanos or pyranos. This, okay, the C5 group will attack the functional group and it will result in the formation of new asymmetrical carbon atom at C1. Okay, new asymmetrical carbon atom will be formed at C1. Okay, when the C5 group attacks the C1, the functional group. In case of glucose, it is C1. In case of fructose, it is C2. Okay, when this fifth penultimate carbon atom forms a bond link, okay, hemiacetal link with the functional group, it results in an additional asymmetrical carbon atom. Asymmetrical carbon atom is nothing but a carbon atom whose four valencies are compensated by four different atoms. Okay, yes. So a new asymmetrical carbon atom will be formed at the C1 position. Okay, so that is called anomer. Okay, so the new asymmetrical carbon atom will have the orientation of the hydroxyl group. If the hydroxyl group is above the plane of that ring, then that is beta anomer. If the hydroxyl group is below the plane of the pyran ring, then that becomes alpha anomer. So we normally denote it as either alpha or beta depending upon the orientation of the hydroxyl group with the plane of the pyranose ring. If it is above, it is beta. If it is below, it is alpha. So mostly glucose will exist in the blood as beta D glucopyranose. Okay, that means it will be in the beta form. So in the newly formed asymmetrical carbon atom, the hydroxyl group will be above the plane, and the hydroxyl group at the C5 position, it will be on the right hand side, and glucopyranose ring. So predominantly it exists in pyranose ring form. So this is how isomers are classified. Yes, so we'll look into a next case with an interesting case and also an image based question. A 60-year-old chronic alcoholic complains of epigastric discomfort and recurrent diarrhea. On examination, he has memory disorientation, exfoliative dermatitis, and present on sun exposed areas. If you see the images, he has dermatitis on the sun exposed area, neck, okay, arms, okay, the sun exposed areas has dermatitis. The clue here is chronic alcoholic. A chronic alcoholic is complaining of diarrhea and dermatitis, memory disorientation. So what can be the probable diagnosis? We have studied in the vitamin section, especially in the water soluble vitamin, 3Ds of niacin, right? Yes. So what are the 3Ds of niacin? Diarrhea, dermatitis, dementia. The clue here is memory disorientation. Okay, dementia. Suppose if this is not treated, it will result in death. That is the fourth D of niacin deficiency, which is pellagra. Okay, so the patient has all the 3D: diarrhea, exfoliative dermatitis, memory disorientation. So the question is, what is a probable diagnosis? The options are beriberi, pellagra, megaloblastic anemia, and scurvy. We know beriberi is because of the deficiency of thiamine, and pellagra, it is due to the deficiency of the vitamin niacin, and megaloblastic anemia, it is due to the deficiency of vitamin B12, and scurvy, which is due to the deficiency of vitamin ascorbic acid. This person has the classical symptoms of pellagra, that is niacin deficiency, the 3Ds of niacin deficiency. So the probable diagnosis here is pellagra. So the same question, we'll see what are the causes of pellagra. Alcoholic, yes, and presented with diarrhea, dermatitis, and dementia. So what are the causes of pellagra? If you see, these are the list of causes of pellagra. First one, the most common, people who are consuming maize as their staple diet or jowar as their staple diet. Okay, maize, corn. Okay, people who are using or consuming corn and jowar as their staple diet. The next cause is deficiency of another vitamin, which is nothing but pyridoxine B6, will result in niacin deficiency. We will see how. And then other two disorder are Hartnup disease and carcinoid syndrome. Hartnup disease is nothing but there is a defect in the absorption of amino acid tryptophan. We know amino acid tryptophan is the one which will synthesize niacin in our body. Okay, so the deficiency of this amino acid will result in the deficiency of vitamin niacin, which presents as pellagra. The next is carcinoid syndrome. In this syndrome, okay, all the tryptophan will be shunted to the synthesis of a neurotransmitter called serotonin. So, tryptophan will not be available to synthesize niacin, which will result in pellagra-like manifestation. The other drugs or other causes of niacin deficiency are anti-tuberculous drug, ATT, okay, that is isoniazid, and if there is malabsorption in the intestine where the vitamin will get absorbed, or if it is not taken in the diet. So these are the common causes of pellagra. Okay, so we'll see the cause in detail. What happens when the person consumes corn as their staple diet for a long time? If you see in corn, niacin is not available in the free form. It exists in the bound form called niacin. Okay, free niacin is not available for absorption. So how this niacin can be converted to free niacin? By alkalinizing the corn. Okay, so processing the corn in an alkaline pH, okay, at the pH of 11 will result in the conversion of niacin to niacin. So usually people consume or cook maize in an alkaline pH so that niacin will be converted to niacin and niacin is available for absorption. Whereas in case of jowar, why there is a deficiency? This jowar will be rich in an amino acid called leucin, and this amino acid will inhibit an important enzyme which helps in the formation of active form of niacin. Niacin is converted to NAD, okay, nicotinamide adenine dinucleotide. So for this conversion, you need an enzyme called QPRT, quinolinate phosphoribosyl transferase. Okay, this enzyme will be inhibited by leucine. Okay, so leucine will be present in higher quantity in Jover. So this leucine will inhibit this important enzyme so that active form of niacin will not be formed. Okay, coming back to the same question which has been asked in the recent entrance exam. A 65-year-old chronic smoker and alcoholic. So this has a lot of distracted. Okay, he's also a smoker and alcoholic who suffered from non-specific symptoms like he has painful swallowing, insomnia, lack of sleep, epigastric discomfort, and recurrent diarrhea. On examination, he had disorientation, stomatitis, that is inflammation at the angle of the mouth, and exfoliative dermatitis. So here the classical features are again dermatitis, disorientation, and diarrhea. Okay, so they have started him on treatment with nicotinamide and he has improved. The rashes has improved and other symptoms reduced. So they have given a clue in this question. If you see here, they have supplemented him with a nicotinamide. So what could be the probable diagnosis? It is very easy and very straightforward, right? Yes, it is niacin. Okay, the person has suffered from niacin deficiency. On supplementing niacin, the symptoms has improved. Okay. So with this, we have concluded part 1 of image-based or case-based question. We will discuss the other questions, other possible image and case-based questions in the second part of this session. Thank you.